Hello everyone. Now let us solve some problems on the inductors. Okay, in that first question is, if an inductor has 400 turns, is wound on iron core, the length and radius of the inductor are 0.5 meters and 4 centimeters respectively. Then calculate first question inductance of an inductor if relative permeability of iron core is 800. Second question is induced voltage in the inductor if the current changes from 0 to 4 amps in 0.3 seconds. Suppose this is the iron piece, let it be piece of wire. Okay, if you want like this, okay, this is called inductor, and suppose it is iron piece, this is called iron core. Okay, this is the inductor. Okay, here these are the number of turns. These are the number of turns. This is called iron core inductor. Suppose if we remove this iron material, this is called air core inductor. Okay, if there is no core inside the inductor, this is called air core material. Sorry, air core inductor. So what are the given values? Number of turns is given, that is 400 turns, and length and radius are given. So what is the length? Length is equal to 0.5 meters. Radius is given, r is equal to 4 centimeters. Convert this into meters. 4 into 10 power minus 2 meters. Okay, so what is the first question? Inductance of an inductor if relative permeability of iron core is 800. So relative permeability means mu r is given 800. So what is the mu naught? Mu naught is equal to 4 pi into 10 power minus 7 Henry per meter. So what is the formula for inductance? L is equal to mu n square A by L. So this can be written as mu naught into mu r into n square into what is the area for conductor? So it is in circular shape. So the area for conductor is pi r square divided by L. Substitute these values in this equation. You will get 4 pi into 10 power minus 7 into 800 into 400 square into, so what is pi into 4 into 10 power minus 2 whole square divided by L value is 0.5, that is length. So what is the inductance? If you solve this, you will get 1.617 Henry. Second question, induced voltage in the inductor if the current changes from 0 to 4 amps. Okay, so here current is changing, let it be I2 is equal to 4 amps, I1 is equal to 0 amps, let dt is equal to 0.3 seconds. So what is the voltage across inductor? VL of t or VL is equal to L di by dt. So L into I2 minus I1 by, okay, this is T2 minus T1, T2 minus T1. So what is the L? Previously we get 1.617 into I2 4 minus 0 by 0.3 seconds. So what is the voltage? You will get voltage is 21.5604 volts. Next question, the inductance of an air core inductor is 5.6 millihenry. If air core is replaced by iron core, then inductance becomes 1.9 Henry. Then what is the iron core relative permeability? What is the given data? Inductance of air core is given. So let it be L1. L1 is equal to 5.6 millihenry. Okay. Next, if the air core is replaced by iron core, then inductance becomes 1.9 Henry. So let it be L2, 1.9 Henry. Next one, what is the iron core relative permeability? So the relative permeability of air is 1. Okay. So remember this. Now, what is the formula for inductance? L is equal to mu naught mu r n square by A by L. Here, for both inductors, mu naught is constant, number of turns are constant, cross-sectional area is constant, L is constant. So, what is the remaining things? L is directly proportional to mu r. Okay. So, from this, mu r2 by mu r1 is equal to L2 by L1. So what is mu r2 now? L2 1.9 by 5.6 m into 1. So you will get 339.2857. Next question. The current in a 4 Henry inductive coil varies with the rate of 6 amperes per second. Determine the voltage across the coil and energy stored in the coil after 3 seconds. What are the given values? L is equal to 4 Henry. Okay, rate of current, that is di by dt is given 6 amperes per second. Determine the voltage across the coil and energy stored. So first find the voltage across the coil. What is VL? VL is equal to L di by dt. So what is L? 4 into 6, that is equal to 24 volts. And next one is energy stored in the inductor. So what is energy stored in the inductor? EL is equal to half L IL square. Here di by dt is given, that is 6 amperes per second. Okay, now how to find current? He is asking in 3 seconds. So 6 into 3, that is equal to 18 amps. Okay, here that is 6 amperes per second into 3 second. 3 second, second cancel. 3 into 6, 18 amperes. Okay. So what is EL? Half. What is inductance value? 4 to 18 whole square. So if you solve this value, you will get 648 joules. Next question. In 5 seconds, current through the inductor is increasing from 0 to 10 amps and producing a voltage of 15 volts. Then calculate the inductance value. What are the given parameters? In 5 seconds, let it be dt is equal to 5 seconds. Current is increasing from 0 to 10 amps. That is di. Di is equal to 10 minus 0. That is 10 amps. Next, producing a voltage. V is given. V is equal to VL is equal to 15 volts. Then calculate the inductance value. So what is VL? VL is equal to L di by dt. From this expression, 15 is equal to, what is L? So it is unknown quantity, 10 by 5. So what is L? 7.5 Henry. Next question. Following figure shows the current flowing through the inductor with an inductance of 4 Henry and resistance of 2 ohms. Determine the energy absorbed by the inductor up to 4 seconds. In this problem, they given lossy inductor. Lossy inductor means original inductor. So original inductor, how can we represent? Inductor in series with resistance. Okay, this is called lossy inductor. In practice, the inductor is denoting like this. So what is the inductance? 4 Henry. What is the resistance? 2 ohms. Now, write the expression for current. So I of t is equal to from 0 to 2 seconds. What is the current? If we find the equation for straight line, that is, you will get 3t, 0 to 2 seconds. Okay, next, from 2 to 6 seconds, what is the current? 6 amps. So 2 to 6 seconds. Okay, now determine the energy absorbed by the inductor up to 4 seconds. So here energy absorbed is total energy ET is equal to inductor energy plus resistor energy. Okay, so both EL plus ER. Okay, what is the EL or ER? ER is equal to integral P dt. Integral P dt. So what is integral? So integral 0 to 4. What is the P? I square R. Here we know that current. So I square of t into R dt. That is equal to from 0 to 2. From 0 to 2, what is the current? 3t. 3t whole square into what is the resistance value? 2 ohms dt plus integral 2 to 4. What is the current? 6. 6 into 2 into dt. Now what is the ER? 3t square, that is 3 into t cube by 3, 0 to 2 into 2. Okay, so this is 9 into 2 plus 2 into 36 into t. This is 2 to 4. Substitute values. So here 3, 9. In 9, 3 is cancelled 3 times. 3 into 2, 6. So 2 cube. 2 cube means 8 minus 0 plus 72 into 4 minus 2. If you solve this, you will get 192 joules. Now, find the energy stored in the inductor. EL is equal to, again, integral P dt, that is equal to integral 0 to 4 L into IL into DIL by dt into dt. Okay, so this is the power dissipated in the R, power stored, power absorbed by inductor. Previously this value is given. So here you can write EL is equal to from 0 to 2, inductance value is constant 4. So what is the current? Current is 3t and d by dt of 3t dt plus integral 2 to 4 into 6 into d by dt of 6, because 2 to 4 current is 6 amps into dt. So derivative of constant is 0. So this total term becomes 0. Here derivative of 3t is 3. What is L? Integral 0 to 2. This is 3. 3 into 3, 9. 9 into 4, 36. So right here 36t dt. You will get 36 into t square by 2, 0 to 2. So what is the energy? Energy is equal to 72 joules. So what is the energy absorbed? Energy absorbed is equal to, so that is total energy, ER plus EL, 192 plus 72 is equal to 264 joules. For suppose in the same question, if they asking energy stored in the inductor, okay, not energy absorbed in the inductor, okay, remember this one. If energy stored in the inductor means only energy stored by this inductor. So what is the energy stored? Energy stored is equal to EL. Energy stored, only energy stored by the inductor, okay, 72 joules. Resistor will dissipate the energy or absorb the energy, but inductor will store the energy in the form of electromagnetic field. So that value is 72 joules. Next question. Following figure shows the current flowing through the inductor with an inductance of 2 Henry and resistance of 2 ohms. Determine the energy stored by the inductor up to 6 seconds. Okay, from the waveform, write the expression for current. IL of t is equal to, from 0 to 2. So what is the current? So find the line equation from 0 to 2. You will get 3t. So in between 0 to 2 seconds. From 2 to 4 seconds, what is the current? 6 amps. 2 to 4 seconds. Next, from 4 to 6 seconds, what is the current? If you solve that, minus 3 into t minus 6. It is 4 to 6 seconds. So what is inductance and resistance value is given? Inductance resistance is, this is 2 Henry, 2 ohms. But here energy stored by the inductor, okay, energy stored means only consider inductor value, inductance value. So what is the energy stored in the inductor? Integral p dt again, that is integral of IL of t into, that is 0 to 6 L into dIL of t by dt into dt. Okay, so current into voltage. Now what is the inductance? Sorry, energy from 0 to 2 seconds. What is the current? 3t. What is the inductance value? 2 Henry. So what is the current? d by dt of 3t into dt plus integral 2 to 4 6 into 2 into d by dt of 6 plus, okay, right here integral 4 to 6. What is the current? Minus 3 into t minus 6 into 2 into d by dt of minus 3t plus 18 into dt. Okay, so if you solve this, energy stored in the inductor is equal to, you will get finally, this is 2 into 9 into t square by 2, 0 to 2. This value becomes 0 because of derivative of constant is 0. So this total term becomes 0. Okay, so for the last term, 18 into, okay, so you will get here t square by 2 minus 6t 4 to 6. So finally you will get, so if you apply limits, you will get 0 joules. Thank you for watching.